Good morning, students. Today we are going to discuss about the decision tree. So before discussing in detail about the decision tree, we'll discuss what is the today's agenda. We'll first discuss about what is classification, what are the different types of classifications are available, and then we'll talk about use cases of classification and what is decision tree, then terminology which are associated with the decision tree. We'll discuss about that, and finally we'll visualize the decision tree if time permits. Now, first of all, I would like to tell you why we are studying the decision tree and how it came into picture. So, decision tree is one type of classification model. So, what exactly the classification is? See, when we are having a certain data set and when we are trying to divide the data set into different categories or a different label, then it is called classification. Take a simple example. Suppose you are having images of cat and dog in a data set and you're asking your model to segregate cat and dog in a different folders. So this is nothing but classification. Or take another example like a person is having disease or not. You want to categorize a person having disease and the person who don't have disease. You want to categorize. So this is again the classification problem. So whenever we are trying to solve the classification problem, there are different way of solving the classification problem, or we can say different models are available with the help of which we can solve the classification problems. And it's totally depends on the data set that which type of classification model we can use. So what are the different classification models are available with us is one is decision tree, second is random forest, navy Bayes, and KNN. And today's discussion will have about decision tree. So what exactly the decision tree is? With the name you can understand decision tree is nothing but it's like a tree structure. The graphical representation of a decision tree will be like a tree. So we'll try to find all the possible solution with the help of decision tree. And how we are going to take the decision with the help of certain condition. So suppose I want to take a final, suppose we have a problem. We are saying that I should go to restaurant or I should go to restaurant and I should eat or I should go for a sleep. Okay, I want to take that decision. So first of all, if I want to eat something, I should feel hungry. So first of all, I'm asking question to myself that I'm hungry or not. If I'm not hungry, then I'll sleep. No, there is no further discussion about that. So the decision will be you can sleep if you're not hungry. Now suppose I'm hungry. If I'm hungry, I should have money to go to restaurant or buy a hamburger. Fine. So if you have $25 in your hand, you can go to restaurant. If you don't have $25 in your hand, then you cannot go to restaurant, but you can buy a hamburger with less cost. So you have taken a certain decision as per the condition. So this is nothing but a decision tree structure. Fine. Now I hope it's clear what exactly a decision tree. I'll just will have a quick review on this. A decision tree is a graphical representation of all the possible solution to a decision based on certain condition. So suppose we take one more example here. Suppose I'm saying that I get a new job offer, so I should accept the job offer or I should reject the job offer. So my first thing is whenever I'm saying that I want to switch a job, my first thing is what is the salary. So if salary is at least $50,000, then fine. I can consider. If not, then directly I'll decline the job offer. If salary is $50,000, then I want to see some other parameters also, like how much distance it is from my home or not. That is my second parameter which I'm trying to consider here. So how much I have to commute. If it is within 1 hour or not. If it is commute is more than 1 hour, yes, then I'll again decline the offer. If it is within the 1 hour, then I have another condition that I love coffee. So if my office is giving me a free cup of coffee every day, then there is another added advantage into it. So yes, they are providing a coffee to me. So definitely I'm going to accept the offer if salary is greater than $50,000 and I have to travel less than 1 hour and plus they are giving me coffee every day free of cost. So definitely I'm going to accept the offer. Otherwise, I'm going to decline the offer. So I have taken the decision to accept the offer or decline the offer through some conditions. Okay, using some conditions, I have accepted the offer as well as or I am going to reject the offer. Now, what is what are the terminology available in the decision tree? When we are talking about terminology, the first is a root node. This is called root node, and other nodes are called child node or leaf nodes. Okay, so in detail we'll discuss again what are the different terminology which we are having. We'll take a certain example again here. Suppose I'm having a data set which is consisting of three columns: color, diameter, and the label. So through the color and diameter of that particular fruit, I want to label the fruit that it is a mango, grape, or lemon. So I have a color of the fruit, I have diameter of the fruit, and the label of the fruits. And using these three, I want to categorize, I want to classify my data into three categories, that it is a mango or a grape or a lemon. Okay. So now the question is, which should be my root node? What should be my root node? My node should be a color or a diameter. So that is the biggest question here, through which I should identify the label of the tree. So suppose in the first time I'm expecting that diameter is a root node. If diameter is greater than 3, then I'm saying it is, if it is greater than 3, then it can be mango or it can be lemon. If it is less than 3, then it is grape. So my first parameter I have taken, that if diameter is greater than 3, it can classify into true class, and if it is less than 3, it classify into false class. Fine. Now further we have divided till here. Okay. Now the second thing is, now I want to see what is the color of that fruit. First I segregated through diameter, and the second time I'm segregating through color. If color is yellow, okay, in this case, it's already segregated because it's a grape and its radius is 1. So it's already segregated. But in the case of mango and lemon, again we have to classify because both are having same diameter. So I have to look into the color option also. So if color is yellow, it means if color is yellow, it means it is mango, and if it is green, it is, if color is yellow, it is lemon, and if color is green, it is mango. So I'm classifying using this. Fine. So there are different way of classification here, and there could be different questions or different conditions through which we can classify the data. Okay. Now just a quick overview. Okay. If the color is, if I'm saying if the diameter is greater than 3, if it is true, then it could be lemon or a mango. Then again we are asking another question, if the color is yellow or not. If the color is yellow, it will fall into one category, otherwise it will fall into other category. Fine. Now, whenever I want to construct a decision tree, so always will lie on the algorithm, which we'll call it as a CART algorithm. So CART algorithm we are going to use here to classify or to build a decision tree. So how CART algorithm works, we'll discuss with the help of different terminology. So you'll have a better idea that how CART algorithm works. So now the question is, if I want to construct a decision tree, what should be my first question? How I can segregate left child, this should be my root node, this should be my left child node, and this should be my right child node. So this is the biggest question here, that how I can construct a decision tree. What should be my first question to ask so that that could become a root node. Okay. So now suppose we have, I want to play. I want to play a game, and it depends on these parameters: outlook, temperature, humidity, and the winding. So if a person wants to play, he has to look into these features or look into these categories, that what is the temperature on that particular day, what is the humidity of that day, is it windy or not, and what is the outlook. So accordingly, I want to take a decision that I should play or not. So now the question here is, what should be the first node here? I should take outlook, temp, humidity, or windy as a first node. So that is the question. So how I can choose the first attribute to be a root node? How I can decide that I should split my tree in such a way so that I can construct a good decision tree which will give me better accuracy? That is a biggest question in the case of decision tree. So whenever we are talking about decision tree, we should know certain terminology, which is like, first is information gain, second is reduction in variance, third is chi-square, and fourth is Gini index. So we'll discuss one by one what are those terminologies. Okay. So before discussing all these things, before discussing in detail about the decision tree and the cart algorithm, we should certainly we should aware about certain terminology. The first terminology is entropy. So before understanding the entropy, we should know the concept of impurity. What is impurity here? See, impurity plays a very important role to select a particular attribute. See, I'll tell you a simple example. What is it? Impurity is, suppose I have a bowl or a box which is consisting of a fruits and other bowl which is consisting the label of the fruits. So a bowl is having all apples and the bowl of label is also consisting of label of apples. So if I'll pick any apple or any label, definitely will be having no mismatch, because every fruit is apple and every label is also apple. So definitely the information gain here will be highest and there is no impurity in this case. The impurity is zero in this case. So whenever I'm saying impurity, impurity plays a very important role to the calculation of entropy. And with the help of entropy, we are going to calculate the information gain. So I should know impurity, I should know entropy, I should know the information gain. So this is the flow. So I hope you understood what is impurity. Impurity is nothing but how pure your data set is, how best you are able to select the data as well as the label consisting of that data. So if there is no impurity, it means the accuracy will be highest in that case. Okay. In first case, we have seen that all are having apple fruits and labels are also apple. So impurity was 0. Okay, but in this case, you have different fruits and different labels corresponding to that. So definitely the impurity will be not equal to 0 in this case. Fine. Now, what exactly the entropy is? Entropy is nothing but it defines the randomness of your data. Okay, randomness of your data means it is one measure of measuring the impurity available in the data. The more impurity you are having, it will affect the entropy of your data here. Okay, see here what I'm saying. What we are having here, we are having the concept. Suppose I have suppose the probability of yes or no is 0 and 1 here. Okay, the probability of yes or no is 0 and 1 here. When it is yes, then it is 0 and 1. When it is the highest entropy we are having at the place of 0.5. So if the probability is 0 and 0 or 1 in this case, it means it is highly pure or highly impure. Your data is either highly pure or highly impure. Therefore, we are saying entropy value is always 0. If the probability is 0.5, in this case the probability is 0.5, then entropy value is the highest, which is 1. So impurity is representing the degree of randomness. If the data is completely pure or completely impure, then randomness will be always 0. So I hope it is clear that what is entropy. Now I'm talking about information gain. So information gain is nothing but it's a measure for reduction in the entropy, or we can say decide which attribute should be selected as the decision node. The highest the information gain, that node will become the root node here. So whenever I'm saying I have more information gain because of so and so attribute, that attribute will become the root node for my tree. So to calculate the information gain, we have a formula which is information gain equal to entropy of whole class minus weighted average multiplied by entropy of each feature. So if I want to calculate the highest information gain of any attribute, or I want to know that which attribute should become a root node or a parent node, then I should calculate the information gain. To calculate the information gain, I should know the entropy of each class minus I should know the weighted average multiplied by the entropy of every feature which is present in the image. So in the next class, we are going to discuss, we'll discuss one of the example so that you will easily understand that how decision tree works. Okay, so this is all about the theoretical concept of decision tree. Next class we'll discuss the practical or mathematically how